Hello, let's quickly look at this particular question, and we have some exciting question in this particular class that I want to look at. Now, the first one says that the sound is produced in wind instrument as a result of the vibration of dash. The answer to that question is what? Not by piece of wood, but by what? Air column. Don't forget sound. There are some things you must know about sound. That sound is a longitudinal wave. Sound is what? Is can travel through a material, is a mechanical wave. Sound is what? It cannot be propagated through what? Polarization. It cannot undergo polarization. Then another things that you need to know. Don't forget that sound travel faster in solid than in liquid and gas. Let me go to the next question, number 2. That said, what the graphical representation of pressure law is always passing through the what? Through the origin. Sorry, I repeated it twice. Through the origin only if the what? Temperature is measured in thermodynamic temperature. That is when if it's measured, if the temperature is thermodynamic. The thermodynamic temperature is also not, can also be likened to the Kelvin temperature. So take note of that. Fahrenheit, no. Celsius, no. The Rankine, no. Please go and do your assignment. What is the lower fixed point of Rankine temperature? And upper fixed point of Rankine was scale, rather. Then Fahrenheit scale, go and find out what is lower fixed point and upper fixed point. For Rankine scale, all these ones are units to measure. This is Kelvin. Temperature in Kelvin. That is what we call temperature in what? In Kelvin is thermodynamic temperature. Rankine scale, we have it that we have Fahrenheit scale. Although basically Celsius scale is what? Is fundamental. Kelvin scale is fundamental what? Unit for temperature. Now let's go to number 3. Number 3 says an alternating current having the wave form shown in the diagram above. Below is or above is represented by what? S equal to S naught sine WT. So that means the graph is a sine graph. So it's showing everything that we needed. Now X naught is the maximum what? Value of the AC. Then this is the instantaneous value of the AC. So take note of that. So the maximum value of the AC is maximum value of AC. That means maximum displacement produced by the AC. And from here, from P to Q, is what that is doing that for us. P to Q is the maximum. So let's see which of the following represent X naught, that is maximum. P to Q, then PQ. The principle of moment of force is used to measure what? Mass. While the principle of what? Of Hooke's law used to measure force or weight. Now the diagram above shows what? The magnetic field due to what? Due to A, the current carrying straight conductor. The earth meridian non-solenoid circular coil. The diagram shows what? Because there is a current here now. So the what? There is a current that is moving. For them to show an arrow here, it means there's a current, and that current creates what? Without the current, no circular. Don't forget that current is very important. It's the current that creates the field. Now, that can be explained. Don't forget this diagram explains direction of magnetic field, which is what? When the current is going, your direction of thumb is direction of current, while the direction of your coil finger right down low is direction of field. So if I'm going up, the field will be what? Anti-clockwise. If current is coming down, the field will be clockwise. So the answer is A. The density of water. Let me clean this part. Permit me. Okay. The density of water is what? See, the density of water is 1 gram per centimeter cube. Is water. And the density of ice. What is ice? Ice is what? 0.9 gram per centimeter cube. While the height of ice is 0.9 gram per centimeter. Calculate the change in volume when 90 gram is completely melted. Now, the change in volume, let's calculate the volume of water first, which is what? Mass over density. Don't forget density equal to mass over volume. These are basic formula you should know. The mass is what? 90 gram of, that is the what is to be melted, divided by what? 1 gram per centimeter cube. What I would have now is what? 90 centimeter cube. That means V of ice is equal to what? 90 divided by what? 0.9 gram per centimeter cube. So what I would have now, you would have what? 100 centimeter cube. In fact, that is this one of the reasons why when you place your water inside the refrigerator and it become ice, especially when you are using a kind of a bottle or maybe a broken container, it is very dangerous to leave it for what a long time inside water. Maybe like glass, put the water in the glass and or the coke or the liquid inside the can that is broken, a broken can. It can affect it because there will be expansion, and that's what is happening here. So change in volume will now be equal to what is change in volume now? It means volume of ice minus volume of water, because now that will now lead us to what? 100 centimeter cube minus what? 90 centimeter cube, and that would was 10 what? Centimeter cube, which is the change in volume. So we are going to have our answer as what? 10 centimeter cube. Now they say the thermometric property of mercury is based on the change in dash. A, resistance with temperature, that is resistant thermometer. Pressure with temperature, no, that should be about a constant gas thermometer. The answer to that question is D, which is volume with temperature. When both object and each image move together in the same direction relative to the observer, then there is what? No parallax error. When the image is not moving together with the object, it probably the image is perpendicular to the object. For example, now if I have a bucket here filled with water and the object is here, now what normally the object is here, now bent here, let's say bent here to appear here. Now to the observer that is looking here, observing, you notice that what? It has created an apparent image or apparent depth. So if what the image and what the object are not moving together, normally if they are moving together, it will not show you, it will not show any parallax error. But when they are what? They're bent, experience that you are what? It will show parallax error. So in that case, when the object and each image move together in the same direction, but if they are moving, you are not moving in the same direction to the relative to the observer, then there will be what? Parallax error. That is what happens when you place a coin, which is a real depth. This is a real depth, and it now appear coming up. The coin now, is coming up now, meaning that it's not moving in the same direction with the what? With the object. So that's why it appear to be like that. The next question, number 9, says what? Look at the diagram. They say the weight 50 Newton and 80 Newton are hung as shown in the diagram below. Find the moment at point P. Find the moment at point P. The moment at point P can be gotten by what? Using what? Taking moment about P, about O. The moment at point O rather. Now what is the moment of 50 Newton at point O? So that will give us what? 50 Newton times what is the perpendicular distance when you take moment at point O? Is what? 3 meters. That means this one. So that will give us 150 Newton meter. Then what is the moment of what? Of 80 Newton at point O, about point O. That will give us 80 Newton times what is the distance apart, which is what? Perpendicular distance rather. Now be 320 Newton meter. That means this one is 320 meters. So let's see. The moment at what? That means this one will not create an equilibrium because the clockwise moment is not equal to anti-clockwise. So the moment at 50 Newton is 15 Newton meter, 80 Newton is no. Moment at 50 Newton is 200 Newton meter, no. Moment at 50 Newton is 150 Newton meter and 80 is what? 320 Newton meter. Yes, this one is correct. That is correct. Now, the last one, which is what? The last question. It said the gravitational pull between two bodies is 20 Newton. Find the gravitational pull when their distance of separation is doubled. Now, gravitational pull is talking about the weight. And weight is what is equal to GME over R square. So that is gravitational pull. Or we can write that one. Okay, sorry. GMM over R square. That is gravitational pull. So which is the gravitational pull of the earth is the weight, where the that's what. Now, if we keep every other parameter constant and consider only the weight and the force, we can say W R square is equal to constant. We can say that. Then if you do that also, we can also create a variation where weight varies with alongside with radius. That's what W1 R1 square equal to W2 R2 square. So if you ask W1, let's say it's 20 Newton. R1 is what's R1 there? R1, the distance apart. We are not giving. Okay, let's say R. W2 will be what? Dash. If what? The distance, let's say what? The gravitational pull between two bodies is 20 Newton. Find the gravitational pull when their distance of separation is doubled. So let's say R2. I doubled R2. R2 is now doubled. That's 2R. So how do you find it? What we are going to do now is that. What we're going to do now is this. We are going to say, look at the board. W1 R1 square. That means W1 is what? 20 Newton. What about R1? R1 is R. R1 is R times R square. W2 is what? Unknown. R2 is what? 2R all square. So how do you make W2 to the formula? Divide both sides by 2R all square. 2R all square. This one cancel this. So what do we have as our final answer now? So W2 will now be equal to, and this is 4R square. If you take square root, square of that of 2R and R. Now, if you have 2R all square as 4R square, we now go to 20 times R square divided by 4R square. So what will now be my answer? R will cancel R. So our answer will now be equal to what? 5 Newton. So option A says what? 20 Newton. Option B says what? 13 Newton. Option A, 20 Newton. B, 13 Newton. C, 10 Newton. And D, 5 Newton. So this D is the answer to that question. Thank you very much for watching. God bless you.